Okay, and then the next thing I can do is to do this calculation here. I have to figure out what is what is 90% of 60, and that would be what, 54. And I'll just do it step by step. I'm not going to combine steps into one big thing. Okay, 54 minus 10 is 44. So this thing gets reduced to 44. And in this step here, I have to use a simple calculator. Linux people like calculators like this. It's a command line calculator, but it will do all the calculations that I need to do most of the time. 44 times 0.85 is that number. So we have 37.4 times 1.0875. And the out-the-door price is going to be $40.67. Okay? It is something that we know how to do already. This is nothing new. You have been doing this, for many, many, many years. Okay, let me just show you the really confusing part of how to use the postfix notation. The postfix notation is saying that I can basically store a bunch of numbers, and then I decide what to do with it. So in this case, I store these 3 numbers, and then I say, add the last 2 numbers into one, and then add that number to the one before that. Okay, and then what do I do with this number? Okay, use 0.9 and multiply that, and then use 10 and subtract from that number, and then I have to specify 1 and 0.15, do a subtraction, and do the multiplication, and then I specify 1, I specify 0.875, do another multiplication, and I think we need one last multiplication to multiply everything together. Yep. No, I think that's, no, wait, this is a plus and then a multiplication. Yeah. No parentheses. Okay. Now, who do you think would be crazy enough to use, this is what we call a postfix notation? Yep.
Someone who's not used to using the other parentheses, someone who would maybe be programming with not using the parentheses, it has certain advantages, not having to find out which parentheses you have to look at for the operation.
Exactly. So this is a completely parentheses-less, type of notation. Does anyone know, some engineer, doesn't matter which discipline, some engineer who are in their, let's say, 50s at this time, at least. Okay? Ask them about HP calculators. Okay? Because for the longest time, HP, Hewlett-Packard, manufactured a scientific calculator that used the reversed, this is called the reversed Polish notation, RPN, which is also called a postfix notation. And for the longest time, HP calculators, I think even their financial calculators, use this particular method to do calculation instead of using parentheses. Okay, so that's why some engineers can do this in their head. They can look at what we call an infix notation and convert that to a postfix notation without actually having to write it on a piece of paper. They can just do it on the fly and do this translation. I am by comparison a novice, of doing postfix notation. A real, engineer can do this like in a split second. That was mostly done not because engineers are smart or because they want to show off they can do postfix notation. It had to do with the processing of parentheses is more complicated than this. Okay, this is actually fairly easy to do from the perspective of the calculator itself. Okay, and that's why they use postfix notation. It's not because the humans are smart. It's exactly the opposite. It's because the machines are dumb, and therefore they have to rely on the people to do the translation, and then the machines can be dumber and using less expensive hardware to do the same thing. Okay, so let's go back to our example here because we're going to do some nesting, right here. In fact, I will probably think that we need 3 levels of nesting. So we'll go ahead and do something like this. Whoa, what is that, saying? Okay, I think we need one more because the first one is going to be the square of. Oh, okay, I think that's enough. So basically, with the 3 join operations, let me just let me just spell it out first, and then I'll explain what it does. So the first part is the square of with a space, and then this one here obviously not world because we don't want to find the square of the world. We want to find the square of x. So we replace the second part with the value of x, and then this part here is just a space followed by is followed by another space. Okay, and let me just show you what it does, and then we'll go back and explain how it gets it done. Run the program. I input 7, check it, and it spells out the square of 7 is 49, which is exactly the way I want it. So the next question is, how did it do it? Okay, now just like in our calculation, it starts with an innermost calculation. So in this case, the innermost portion is this part here. Join the square of x. Okay. In other words, the first part the first part that gets generated is the square of 7. And then that gets joined with the outer join here, the middle join, and it is joined with a space and an is. And then it gets joined one more time with y. If I want to show this in a text editor, this is what it should look like. Okay, so let me see if I can show both at the same time. Okay. I'll use this notation. Join the square of x gives us the square of 7. Okay? And then you take it one level out. Okay, so I'm just going to do this step by step, so bear with me with the middle join is joining with the word is, with the spaces around it. And that will give us the square of 7 is, and then with a space. And then the last one, the entire thing, which has another join on top of everything else, but that join is joining with the value of y. Oops, I take it back. I missed the parenthesis here, another one here, another one here. And that gives us, this entire sentence. The square of 7 is 49. Is that okay so far? I mean, can you guys see which part comes from which particular join statement? Okay, let me just repeat that. The innermost one gives us this portion. By joining that with x, it gives. By joining that with is, this entire portion here, it gives us the square of 7 is. By joining the square of 7 is with y, it gives us the square of 7 is 49. Is that okay? I mean, it's kind of cumbersome, but the concept of just joining and also nesting, they're not complicated concepts. It's just how do you stack them up to do the things that you want to do? That's the question. So are we doing okay with the slightly more interactive version of Scratch? Yep.
Instead of making the variable x, could you just put the answer times
Yes.
answer?
Yep. Yep. Okay.
Is there a way to store strings in Scratch?
Yes. A variable can store strings.
Okay.
Yeah. So you can incrementally construct a string. So this is one version. Let me save this version first, and then we'll look at alternative ways of doing exactly the same thing. So the next version, I will call this. Oh, let's see. concise. I would make this, very concise square. In other words, I don't even bother with x and y anymore. I can utilize the answer to the question immediately in the calculation. Okay, so we'll go ahead and see what we can do with this one. Instead of using x here, I will just go to variables, sensing, and I will utilize the answer immediately as x. And that kicks this variable out. I will make it go away. Yep.
If you click on one of your things, it'll duplicate it if you want.
Okay.
Click to duplicate it instead of going to the specific tab.
Right. But I cannot duplicate y anymore because I have to compute answer times answer on the fly. So that means I have to actually, well, I guess I can do that. I can just drag it into here, and it won't do it.
You gotta scroll over it because it's on the screen.
Because the operator's pointy-ended and the variables aren't.
No. It's just it's out of space. That's why.
All right.
Okay. But I cannot use x anymore. I basically just have to drag answer over here, duplicate it, and drag it over here. And once again, we are out of space. So we'll go ahead and get this out of the way. Duplicate, put it also here. And then take this away too. Now we have a fairly long statement, and I don't need x or y anymore. So this entire block can go away. I can go to variable and delete my variables. I can delete x. I can also delete y. I don't need a single variable anymore because I am using the answer to the question on the fly to do the calculation as well as to show the calculation in the speech bubble at the same time. So let's just go here and take a look at this rather long statement again and make it wait, say, 4 seconds. So what we want to do, the first thing, the innermost join, is joining the square of and then immediately utilizing the answer. The middle join is joining the square of a particular number is, okay? The outermost join, which is the most interesting one, is calculating the square of the answer on the fly. I don't need to put it into a variable first. Let's go ahead and run this program and see if it works the same way as before. Let's give it 7. And it shows the square of 7 is, in fact, 49. Are we doing okay so far with this? Okay. So let me save this. And then the last version of this program, which has the same effect, is going to construct a string to output step by step. In other words, I'm going to illustrate how you can use the concept of a variable, but in this case, apply all the concepts to a string. Okay. So let's change the name. Let's change the name to string construction. Okay. In other words, this program spells things out, a little bit more clearly than the previous program. The first thing we want to do is to create a variable for the message that I am going to print out. So we can just call this message, or if you don't want to take up too much space, using M is fine in this program. Okay. And what we want to do is to construct the string that will eventually say the square of a number is the numbers squared. Okay, we want to do it step by step. The first thing we want to do is to make M to spell out just the part of the square of with a space. And then what we want to do is to set again. So this time we want M to become the join of itself and also the answer.